When people think about robots, it's easy to assume that we're on the cusp of something big. We hear about self-driving cars and factory automation and humanoid bots that can flip burgers at a moment's notice, and it feels like the science fiction future is finally arriving. But look around, and it's not that clear if that's actually true. Where are all the robots? What we do and often hear about are the less sexy but more important advancements in robotics that are happening quietly behind the scenes. The truly mind-blowing stuff isn't necessarily the robots you can see, it's the ones you can't. They're embedded in the machines you interact with every day, from a TI mess to vacuum cleaners. And they're getting smarter by the second. We're going to explore some of the most advanced artificial intelligence out there, including how a new generation of engineers is designing systems that are capable of solving problems without human help. This is our channel, and today we're answering the extraordinary question: what if robots could learn to think for themselves? Most experts agree that the secret to strong AI lies in machine learning, as opposed to traditional programming, which relies on explicit instructions. Machine learning involves training an algorithm on a vast amount of data. Then it allows that algorithm to recognize patterns and make decisions based on what it's learned. In theory, this can enable a machine to perform any task that a human can do, and potentially even more. But machine learning has a major drawback. These systems only work if they're trained with tons of relevant data. There are whole teams of engineers dedicated to making sure that a self-driving car has enough examples of every possible scenario to ensure that it can navigate safely and efficiently. That takes time, money, and a lot of computing power. However, as we enter the 2030s, engineers are developing a new generation of robots that don't rely on explicit programming or machine learning. Instead, they operate thanks to something called embodied artificial intelligence. Embodied AI doesn't just use data to train an algorithm. Instead, it allows a robot to experience the world directly. It learns by doing things. Now, this might sound a bit familiar because it's similar to how humans learn. We don't have all the answers hard-coded into our brains. We figure things out by interacting with the world around us. Of course, there's a massive difference between a human brain and a silicon processor. But in the past decade, advances in robotics and machine learning have made it possible to create embodied AI systems that are genuinely astonishing. Take the recent DARPA robotics competition as an example. The challenge was to create a robot that could complete 7 tasks in a simulated disaster zone. These included locating people trapped in rubble, helping them escape, and carrying stretcher-like devices to a waiting vehicle. This was no easy feat, and only a few teams were able to meet the challenge, but the winner did so without any human intervention. The winning robot, named Atlas, used a combination of machine learning and embodied AI. It was able to navigate unstructured terrain thanks to its advanced sensors and when it encountered an obstacle, it didn't just stop and wait for instructions. It figured out how to move around it. If it came across a wall, it climbed over it. If it saw a staircase, it went up it. Even when one of the judges tried to trip up the robot by kicking its foot, Atlas was able to keep going. And that wasn't the only impressive thing about the competition. Some of the other entries were equally as adept at handling unexpected obstacles. One team created a system that used computer vision to identify and avoid obstacles. Another developed a tactile sensing system that allowed their robot to feel its way through debris. So, what does this mean for the future of AI? For starters, it shows that robots are becoming increasingly capable of operating in the real world. They're no longer limited to highly structured environments where everything is predictable. They can now handle the messiness and unpredictability of the real world. But that's not all. It also suggests that we're entering a new era of AI research, one that's less focused on building systems that mimic the human brain and more focused on building systems that can solve problems. Embodied AI isn't about replicating human intelligence. It is about creating new forms of intelligence that are better suited to the tasks they redesigned for. Take the DeepMind Labs AlphaGo program. For instance, you may have heard of it. It was the first AI to defeat a human champion at its own game. But AlphaGo wasn't built to play games. It was built to solve problems. Games happen to be a good testing ground for AI because they have well-defined rules and a clear goal. But the skills that AlphaGo developed playing games have real-world applications too. Its ability to plan ahead, learn from its mistakes, and adapt to new information is useful in many contexts. This is the idea behind general-purpose AI. The notion that an AI that can solve one problem can also solve many others. For example, an AI that can drive a car can probably ride a bike, fly a plane, and captain a spaceship too. Now this sounds great in theory, but it's not always easy to pull off in practice. For instance, take the case of OpenAI's GPT-3, one of the most advanced language models in the world. GPT-3 is a general-purpose AI that can generate realistic-sounding text on a wide range of topics. It can write stories, summarize articles, and even hold conversations. But it's not perfect. It can also generate text that's offensive, biased, or just plain wrong. And that's a big problem. If you're using GPT-3 to write an essay, it's not the end of the world if it makes a few mistakes. But if you're using it to control a robot arm in a manufacturing plant, those mistakes could be much more costly. That's why many researchers are working on ways to make general-purpose AI is more reliable and robust. One approach is to give them the ability to reason logically. Logical reasoning is a hallmark of human intelligence. Our ability to draw inferences and make deductions is what allows us to navigate the world around us. It's also what allows us to trust the people around us. If someone tells us that they saw a UFO, we don't just believe them. We weigh the evidence and come to a conclusion based on what we know. This is called inductive reasoning. We use it to make predictions about the future based on what happened in the past. But logical reasoning isn't just about inductive reasoning. It also includes deductive reasoning, which is the ability to draw inferences from general principles. For example, if we know that all dogs are mammals and that Fido is a dog, we can conclude that Fido is a mammal. This kind of reasoning is essential for robots that need to make decisions in complex environments. But it's not easy to teach robots. For years, researchers thought that they would need to program these abilities in explicitly. But recent work has shown that it's possible to teach robots to reason logically through machine learning. One team of researchers at Google DeepMind taught a robot to play a game that involved planning ahead and making deductions. The robot was able to learn the game by playing against itself over millions of iterations. After just a few hours of training, the robot was able to beat human champions. Another team at OpenAI taught a robot to reason logically by having it play a game that involved manipulating objects in a virtual world. The robot was able to learn the game by watching human demonstrations and then practicing against itself. After just a few days of training, the robot was able to perform tasks that it had never seen before. So what does this mean for the future of AI? It suggests that we may not need to program robots to do everything. They may be able to learn what we need them to do and even more. It also suggests that we're entering a new era of AI research, one that is less focused on mimicking human intelligence and more focused on creating new forms of intelligence that are better suited to the tasks they redesigned for. Embodied AI isn't about replicating human intelligence. It is about creating new forms of intelligence that are better suited to the tasks they redesigned for, and who knows, Maybe one day we'll create an AI that's smarter than us in every way, except one. It'll never need to worry about writer's block again. Thanks for watching this episode of C Show, and thank you to our patrons for supporting this channel. If you'd like to get involved, you can check out our support page.